Hello people, so today we will be solving LeetCode daily question 706, which is design HashMap. So what is HashMap? HashMap is a data structure that uses hash function to compute an index into an array of buckets from which the desired value can be found. So HashMap basically is a key and a combination of key and value. So for every key we have a corresponding value related to it. So for example, if we map 1 to 2, then if we print the value for 1, it will show us map 1. So it will print, give us the output as 2. And also it's like in every hash map, we only have unique keys. So for example, if I try to update 1 to 3, so basically this 3 will be assigned to this 2. So if now I print value of 1, it will give me 3. So in HashMap we cannot have duplicate keys, but we can have duplicate values, and for every key there is a corresponding value to it. So in the question we have to basically design three functions, which is put, get and remove. So for the put function, put means we have to assign we have to add the values to the hash map. So for designing hash map we can use ArrayList or an array. Both will do the same work. So what we can do, we can consider index to be key and value. Suppose let's say that the name of the array is nums, so the value at that index would be considered as value. Okay, so what we can do is we can in the put function we have to assign the value at that index, so we can do that nums basically put function takes two parameters, key and value. So in our case the key is index, so for nums index we assign it that value, and then in the get function we have to return the value at that we have to return value present at that index. So we'll just in the get function we'll just return nums index. This will return us the value which is present at that index, and for the remove function we have to remove the value at that index. So what we'll basically do, we'll assign nums index to -1, because in the question it is given that we have to return -1 if there is no mapping for that particular key. So this is the case. So let's code it. We can also use an array, but I'll be using an array list. So list of integer list, and now we initialize it. List is equal to array list. We'll be taking the list of size 10 to the power 6 plus 1. So we can do this in this way, and then we fill all the indexes with value -1. We have taken the size of ArrayList to be 1 to the power 10 to the power 6 plus 1, because it is given in the constraint that values lie between 10 to the power 6. Okay, so we'll just list dot add -1. Okay, so in the put function we have to set list dot set key comma value. So the put function in this put function we have like we have seen, we have to assign the value which is given for the corresponding key. So we'll use list.set function, which basically takes two parameters, the index at which we have to assign, which is our key, and the value which we have to assign. Okay, so and for the get function we have to return the value that is present at that particular index. So we'll just simply return list dot get key. And for remove function we have to basically remove the value which is present at that index. So what we'll basically do, we'll just use the set function. Okay, so here we'll be setting the value -1 because we just have to simply remove, and we cannot use null value. So we'll just be applying we'll just be updating the value at that index to be -1. Okay, so this should work. Oh yeah, and basically HashMap, the basic purpose of HashMap is because it gives insertion, deletion, and updation time complexity to be O of 1, because we'll be directly using the key to update the values, delete, or make any changes to the values. So, okay, this code will not give us a good time complexity because of several issues, and I also will be using a huge size of array list, which is 10 to the power 6 plus 1, so its complexity will not be also good. So instead of this, what we can do is we can use the concept of linked list. Linked list or list node, we can create our own data structure called as, let's say, list node. Okay? And this list node will, in this data structure, will be having key and value pairs and list node, and we'll be linking this. Okay, so we can initialize it list node with int key comma int value, and here this dot key is equal to key, and this dot value equal to value. Okay, so this is the basic data structure, basic creation of the list node. So we will be using this class, and what we can do is we'll have to set, okay, we have to design the put function, get function, and remove function. So okay, for the put function, what we can do is we can initialize a while loop with like current pointer pointing towards the head of the linked list, and head of the sorry, the current pointer could be of type list node. Okay, so of the type we'll be initializing the current pointer to head of the linked list, and we'll do while loop. In this we'll check that if the key has already been present or not. Like we'll check if while current not equal to null. So what we can check is if current dot key is equal to key. So we'll just do current dot value equal to value, and we'll just break from the for loop. Okay, from the while loop, sorry. Okay, and here we know that put function takes two parameters, key and value. Okay, so and okay, let's suppose this comes out to be false, like key is not present in the linked list. So what we'll do current dot next would be equal to new list node. We'll create a new list node of key and value. Okay. So this will be the function of this is how our put function will work. So and for the get function. Okay, get function that takes the parameters as key. So in the get function we'll again initialize a current pointer which is pointing to the current head, Then again we'll use while loop while current not equal to null. Oh, basically we can use current dot next not equal to null. Sorry, not here also. Current dot next is not equal to null. Okay. So current dot next is not equal to null. So what we can do is if current dot key is equal to key, what we can do, we'll just return current dot value. Okay, but if this is not the case, if the key is not present, so what we'll just simply return, we'll simply return -1. Okay, yeah, this is the case. And now for the remove function, for the remove function also takes the parameter as key. So what we'll be doing, key, and we'll be again initializing a current pointer which will be pointing to the head node, the start of the linked list, which is basically, and while we'll also initialize a pref pointer, pref okay, pref it should be equal to, let's create a new list node. This will be just a dummy head for now, list node. -1 comma, let's say -1 comma -1. Yeah, so we'll be initializing and pref pointer will also be acting as a dummy head. Okay, pref dot next would be equal to current. So while current is not equal to current dot next is not equal to null. Current dot next is not equal to null. What we'll be doing, we'll be moving pref is equal to pref pointer to the next, and we'll be while current dot next is not equal to null, or and function, and current dot key is not equal to key. Yeah, we'll be doing, and then current is equal to current dot next. We'll be moving the previous node to be current. Yeah, so current is equal to current dot next. So if one of these condition fails, we'll be exiting from the while loop, and then what we'll do pref dot next should be pointing towards the next node, that is pref dot next. So we'll be skipping the current node. Yeah, so this was the question. Thank you.